Hello React Native developers, what is going on? This episode is everything we love about this series, some plain, honest trigonometry followed by simple yet powerful gestures and animations. So welcome to Can It Be Done in React Native? This week we get our tunes on. Hello guys, I hope you are well. William here, recording from beautiful Zurich, Switzerland. This week we are looking at the iPlayer app from the BBC. This is a suggestion from a subscriber of the show, Seeker Prasad. Thank you so much for sending me such a great suggestion. And please keep sending me amazing suggestions so we can have a lot of fun with them on this channel. And guys, this one is going to be a lot of fun, I can promise you. So here you see we can swipe either at the bottom to select a channel or at the top, and we can just select a channel. When I end the gesture, it snaps to where it needs to snap properly. You see, and I can use some momentum like this. So when I saw this example, I got really excited. I got really excited for three reasons. So the first reason is if we look at the circular gesture at the bottom, this one clearly means trigonometry, right? We have some rotations, but also one thing that immediately got me scratching my head is, so we have you see this big circle at the background, which is maybe, let's say 20% of the width of the screen. So how many, and we know we have 18 channels to display. So how can we calculate the diameter or the radius of a small icon of one of the channel so that for a full revolution, we have 18 small circles? So what should be the radius of a channel to fit the big circle when you see, I mean, here the big circle is a bit bigger than the width of the screen, so maybe 20% bigger. So how do we calculate the size of these small icons? So clearly here there is an interesting trigonometry problem that needs to be solved. The second reason I got really excited is that this app has been done by BBC, and with the examples and the request I'm receiving for the channel, nowadays it's getting. I'm not saying it's impossible. There is a lot of really amazing apps out there. I mean, so many, but it is a bit more and more. It is a bit harder now to find examples from apps which have not been developed by either Google, Facebook, or Apple. There are still a lot of great examples we can look at, but now like the really incredible user experiences are usually like made. You know, it's WhatsApp, Facebook, Instagram, or like all the Apple apps. So I was really excited to find an example outside these three companies. And by the way, I mean, if some developers from BBC are looking at this video and were involved in this project, I want to congratulate you. You did an amazing job. So clearly, I mean, clearly one of you guys really, really understand trigonometry, and that's amazing. And you really also understand like how to synchronize the gestures and so on. So you have built an absolutely spotless user experience, and I wanted to tell you that was to congratulate you. I think this is really incredible what you have built, and that brings us to the third reason I got really excited is that there is a lot of really interesting details in this example. One of which being the two gestures being kept in sync completely. So for instance, you know, this app, I don't think it's done in React Native, but I think that whatever the technology you are using to build such app, I don't think it's a trivial problem to solve, right? Because here I move, so I move the top gesture, so I swipe on the top, and then the bottom is kept in sync. And of course, when I swipe at the bottom, it's like completely seamless. And another interesting detail is also the infinite scrolling. So here we translate on the x-axis, but once we've done a full rotation, we've went through the 18 channel, it starts again. And these are two things we haven't done before in the channel, so I find it to be really interesting. And we know, one thing we know how to do on the channel very well is to move something around, and then once we stop moving it, we snap its position somewhere. And in the Google Chrome example, we had a challenging problem where while the gesture was still active, we needed to snap somewhere, even though we didn't end the gesture. And that was actually quite a challenging problem to solve. By writing a very, very clean implementation, the solution actually of this problem revealed itself to us. That was actually really cool. And I think here the synchronization problem, the same way is gonna, if we do a really clean code, is gonna, just appear, and we will get the synchronization for free if we do everything super clean. And the infinite scrolling, so here we translate on X, but it's actually infinite. It's a new thing, and I think it's a very interesting problem to solve as well. So how would we do this in React Native? So the first problem is how many circles can we fit? I mean, what should be the size of the circle so we can fit 18 channels? So I Googled for this exact question, and I actually found a lot of answers. As it turns out, it's actually a pretty common problem, especially in electrical engineering. So I found this great video. I will put the link in the video description, where so we have a big circle here, and we want to see how many small circles we can fit around. So in our case, the small circles are inside a bigger circle, but that's no problem, because once we calculate this value, we know that the radius of the bigger circle is the radius of the inner circle plus 2 times the radius of the small circle. This is a great video. It's only 7 minutes. I really recommend you check it out. And that gives, so the formula is given to us, which is k is sinus pi divided by n, where n is the number of circles. So we know as n is 18. In our case, we have 18 channels we want to display, divided by 1 minus sinus of pi divided by n. K is r, which is so the radius of a small circle, divided by r, which is the radius of the big inner circle. That gives us small r equals big R times this formula, sinus, and so on. And in our case, so the outer radius is R plus 2 times minus R. So that's how we're gonna fit all this channel into the circle. And then for the size of the big circle, we can take any value we want. For instance, 20% of the width of the screen. I tried this, it looked pretty good. Here we can just set any value. And then we need to translate, okay, each small circle according to the index, right? So we need to divide 2 pi, which is a full revolution, by the number of channel, by 18. And so we need every time so at 0 we have a rotation of 0. For 1 we have a rotation of 2 pi divided by 18. And we need to change the center, so transform the origin of the rotation. That's part 1. Part 2 is going to be building the gesture. For this, we're going to create an animated value called index. Index will contain the value of the current index, and we know that we have 2 pan gesture handlers, one for the top, one for the bottom. And what this pan gesture handler will do is simply index. They will have access to, will share the same index value, and they will simply update this value. Because once we so to keep things in sync, quote unquote, because when we move one pan gesture handler, we update index, and then we move the other one. We need to only look, we cannot look at the translation value of the pan gesture handler, because it moved but from another pan gesture handler. So we only need to know the increment value of the translation. So we will use the diff function from reanimated to only look because at the end the translation of the pan gesture handler is completely out of sync. But if we look always at the increment and we use this increment to update the index, things should always look good. So we use the diff function to get the increment translation. Then we need to transform this increment translation into an index value. Meaning, if I swipe at the top, I need to move from index, let's say 0 to 1. I need to do a full translation of the width of the screen. So translating from width will actually be an increment of 1 in the index. If I, maybe let me go back to the app. Here at the bottom, if I swipe at the bottom, only a small translation, only a translation of few pixels will trigger an increment of 1 in the index. So I'm gonna need for each pan gesture handler to set some ratio, which is gonna enable me to transform a translation into index increment. And the ratio, if we were at the top, is gonna be width of the screen. So to increment to 1, we need to translate to the width of the screen. And here, if we translate to width, we would we will have an increment to half, right? Oh no, less, half of the channel. Not exactly, because it's the circle is bigger, but here we can set a value to, something like width divided by half of the number of channels, for instance. Or width, so the diameter of the circle divided by half of the channel numbers. And then once we end the gesture, we need to snap to one index. So once, either we cannot be in the middle once we end the gesture. For this, React Native Redash will provide all the functions we need to decide the snap point. So the snap point is either the sale value of the current index value or the floor value. And in order to, again, for the snap point function to help us decide where to snap, we need to convert the velocity into divided by ratio, right? Because we need to transform because we are moving an index value and not a translation. Therefore, we need to also convert the velocity into an index value. And we're going to run Spring. Again, we get it from Redash. And I think that's more or less pretty much it. But what do you guys think? Can it be done in React Native? Let's have a look. And before we get started, 2 things. First, if you like the show and you would like to support the channel, you can buy me a coffee and I will give you access to the private GitHub repository where I tinker with all these examples. And of course, if you have a new React Native project coming up, I recommend you check out React Native Elements, Premium Starter Kit for React Native. It's 80% of what you need when starting a new React Native project. Lots of beautiful UI components, static analysis, boilerplate navigation, and so on. So I definitely recommend you check it out. I will put the links in the video description. All right, let's get started. Here I created a boilerplate project using Expo init. You can download this boilerplate in the video description in case you want to follow along with this example. So I received the list of channels, so 18 channels with some metadata such as the thumbnail here. And we have 2 components, thumbnails, which is the top component you see here, and circular selection, which is the component that you see here. So 3 steps. Step 1, we're going to display the channels icon properly. We're going to compute the radius of each icon and do the proper rotation along this arc that you see here. Second step, we're going to create a pan gesture handler, which is going to enable us to rotate across these different channels. And step 3, we're going to also add the translation of these thumbnails to have like this infinite kind of translation on the x-axis, where we can always rotate around the channels. So let's start with step 1. If I go in the circular selection component, here I have a radius of 30, which is just a random value that I set. The inner radius, because if we look at the video, it's actually the small circles are outside the circle, but we have the r, which is going to be inner r plus times r. The diameter of the inner r is width times 1.2. It's a value that works well for me. You can set any value that you want. Height, so here the height variable is, if I go back here, is the height of this component here. So the visible height of the circle. Again, here, this is the value that I selected. You can tweak it and use your own value. And if I go back here, we know that r, so k, r divided by r, so minus r is capital R times the sinus expression divided by 1 minus the sinus expression. So let me create actually a variable for the sinus expression. I'm going to call it maybe a. So is sinus of math pi divided by length, which is the number of channel. So we have length, from the channels, and we know that minus r, lowercase r is inner r times a divided by 1 minus a. And this should give us immediately the proper size of the icon. Let's have a look. So yes, we have it correctly. Now we need to spread these icons along the circle. So I'm gonna add here some transformation. We're gonna rotate, So we're gonna translate x to the center of the big circle, and I'm gonna call this variable cx. Then we're gonna rotate, so on the z-axis, and the rotation is gonna be key, so the index times whatever we need to increment for which for every index. So that would be 2 pi divided by the number of channels. So we multiply by 2 pi divided by the length, and this would be in radius. But of course we need to translate, we need to transform the origin of the rotation to be at the center of the big circle, so it spreads around the circle. So I'm gonna do that by doing a translate y of cy and minus cy. This is how we transform. With the React Native Animation API, we can transform the origin of the transformation. So here I do a translate, and then I translate back to the original position, but then rotate is applied when translate y is cy. So we move the coordinate system every time, and I'm going to create cx and cy. So cx is divided by 2, cy is r, but we need to subtract minus r every time. So it's not, actually these values are not cy and cx. It's here, it should be cx minus r, cy would be a little bit cleaner. Let's have a look. Okay, so now these are really well spread across the circle. So let's go to step 2, which is going to be to create a pan gesture handler. All right, so it looks pretty nice. It's nicely spread out across the circle. Now let's do step 2, which is going to be to create a pan gesture handler so we can rotate this circle. So I'm going to create a component called pan gesture. And this value, okay, let's create the component. So I'm going to create a file called pan gesture.txt. So we need 3 properties. The first one is going to be index. So it's an animated value that contains the current index. This is the most important animation value in this example. We're going to need a ratio attribute because we're going to need to convert a translation on the x-axis to an index increment. And we know that if we swipe at the top or we swipe at the bottom, this ratio is different. So I'm going to set ratio equals number. And we need the number of channels. And we need this number because when we increment, so we go from 0 to 1, but then we go to 17, and then not 18, but 0 again. So we're going to use a modulo of the length to compute the set index. I need to import animated from reanimated. So we get these values here. We are going to create a pan gesture handler from React Native gesture handler, pan gesture handler. We need to put an animated view always as a child. Here it's going to be an empty one. And I'm just going to set an absolute fill to it. Okay, so I need to do some import here. And pan gesture handler from React Native gesture handler. I'm going to need also the state object. We can start creating already the animation values. So I'm going to need value from animated. So we have the state. We need translation x. We need velocity x to calculate the snap point. And we can create the gesture handler using helper function from read dash, which is called onGesture event. I can pass state, translation x, velocity x as parameter. It doesn't resolve the import, I'm not sure why, but we get it from redash. And I need to pass it as props here. Perfect. Now, if I go to channel, I need to create the index value, which we're going to pass to these 2 components. So the most important value in our code, because this is from this value that we drive everything. So we pass it as parameter here and here. So it's from reanimated. Okay. And in circular selection, I need to pass so index, length, and ratio. So for ratio, I'm gonna set a value. So I'm gonna divide width by so half. So if I translate from width, I want to have rotated to half of the channel. So I'm gonna divide by length divided by 2. And index we get as a prop. So we have index is an animated value number. We need to import pan gesture. All right, so now the first thing we're gonna need to do is to create a translate x value, which is simply a preserve offset of translation x. I can pass state as parameter. We want to calculate the increment, so we're going to use the diff function of translate x. So again, we really cannot look at the translate x value because if we move one or the other pan gesture handler, we don't know where we are in relation to the index value, so we can only look at increment in the translate x value, and that's why also we need therefore the preserve offset. So we have the diff, but we need to convert it into an increment in index. So that's why we use ratio. And now I'm going to create a set index function because we need it twice, where you get a value as parameter. So I can create value as animated node number, and you know we're gonna do the modulo, right? Because we go to 0, 1, and so on, 17, and then not 18 but 0. So we do a modulo of value of value by length. I'm not sure, guys, but I think it's because I'm doing the ScreenFlow recording. Like my computer, you see the automatic import don't work anymore. My computer is actually like pretty sluggish right now, and I think it somehow cannot handle the recording and the coding at the same time. It's pretty crazy. So now so we have our increment, we know how to set the index. So let's update this value using use code. Once we create this value, once this value is updated, we will apply the proper rotation to actually see it in our code. So I'm gonna need use code, and I'm gonna create a block, no dependencies. So I'm gonna import block as well, and I'm gonna do a set index of I'm gonna subtract index to increment. I need to import sub. Looks good, doesn't complain. And now if we want to see actually the index value moving something, I'm gonna create an animated value here, an animated view, sorry. So animated view, we're gonna have a rotate Z, and again here we're gonna need to translate the origin. So I'm gonna do a transform, so translate y is r minus height divided by 2. We do the rotate Z, which we're going to interpolate from the index value, and here we need to transform the origin, we need to translate back on the y-axis. So I'm going to have translate y is, so minus 1 of this, so it's going to be minus r plus height divided by 2. Now rotate Z. Rotate Z, we interpolate from index. So we have interpolate index, input range we need to import interpolate. From animated. So input range, we go from 0 to length, and the output range is from 0 to a revolution, which would be 2 times pi. Let's have a look, see if anything is working. Nothing is working. Let me check index. We don't seem to update the index value here. Set index is set index. Sorry guys, sorry about that, of this value. Let's have a look again. Okay, so here it moves super nicely. I just need to revert. I mean, you couldn't see it, but I was actually moving my finger in the other direction. So now this works well. We can add the snapping behavior. So here, that's why I have a block. So we're gonna do a first thing, which is if the state. So okay, we need to create 2 new animation values: a clock to do the snapping, right, for the spring animation. So I'm gonna create a clock, and we need a value, a Boolean value, to tell us if we need to snap or not. So should snap equals new value 0. 0 if we shouldn't snap, 1 if we should snap. Okay. So if we start the gesture, so state equals state.began, we want to make sure we stop the clock. So in order to interrupt the previous animation, if there were one going on. So I need const equal stop clock. I'm gonna need also not clock running. Okay. If we end the gesture, we need to do 2 things. First, we need to set should snap to 1, so in order to trigger the snapping behavior. But in order to not set this variable twice, we are going to set the state to undetermined state dot undetermined. So that's good. And now if we need to snap, so if should snap equals 1, we can run a set index, which contains a run spring from redash. Clock is the first parameter. Second parameter is value, so it's index. Then the destination. The destination, we're going to use the snap point function to decide where we need to have a destination. And then the last parameter is a spring config. Here we have a default value provided. Let's see if we need to update it. So snap point, which parameter do we need? I think the first one is the value, it's index, then the velocity, but the velocity we need to convert into an index increment. So we need to divide velocity x by the ratio, pretty standard. And then our snap points are pretty easy. It's either sail of index or floor of index. We go to either the lower integer or index or the higher integer value. So I need to import sail, floor. One last thing we need to do is, so we update this value when the clock is over, the animation is over. So when not clock running, we need to set should snap back to 0. Let's have a look. So it works pretty nicely, except for the snap point which are reverted, so it should be minus ratio here. And yeah, I think it looks pretty good. So now let's take care of the thumbnails here. So if I go back to the thumbnail components, I received the index as animation value. So index is animated value. And here we can add our translate X. So I'm going to wrap it into an animated view. And we have our transform translate X. So translate X, which we interpolate from index, but let's not forget we need to do actually the infinite scrolling. So let's have a look. So interpolate index input range. We go from, so key is the current index, the index of the component. So we go from key -1, key, or key +1. Output range. So if we are key -1, we translate to with, because we want the image not to be on the left side but already on the right hand side. So with, here if we are at key, we are at 0. If we are at key +1, we are at minus with. Let's have a look. I need to import the interpolate function from animated. Output range. Oh, sorry about that. Okay. Doesn't seem to be moving. Oh, okay. So actually it is moving. So it looks pretty good, except you see for the first one, which makes sense because we go from 17 to 17.9, 17.99, and then it's not 18, it's back to 0. So for if we're on the first thumbnail, we need to handle this use case. So I'm going to do if key equals 0, we need to write another interpolate. On index as well. So input range, we go from, so actually you can have length here from channels. We go from length -1 to length to 0 to 1, and the output range. But then I need to sort again these values. Actually, and then once we are at 1 plus 1, so from 1 to 17, we also need to switch the size of the card. That's why we get the infinite scrolling. So here if we have length -1, we would have with to 0. At 0 we have 0. 1 we have minus with, but then we have with again. So we translate from 0 to minus with, and once we're at more than, index is more than 1, so we don't see the card anymore, we move it to the other side of the screen. So we use with, And so what I need to do here now is simply what I need to do here is simply reorder these guys here, because I cannot use, I need to have increasing values. And so my order is 0, 1, 1, length, -1, length. And my input range is gonna be, so for 0, well, I'm confused. For 0, I have 0. 1, I have minus width. Length -1, I have width, and length 0. So let's have a look. All right, so here you see it's moving super nicely. We do have like an infinite scrolling. So here I am coming from the other side, and you see killing Eve. Perfect. So now let's finish the job. It's gonna be very simple. We're gonna add a pan gesture handler to the thumbnail. And so here I have content. So I'm gonna put it here. So we know already, pan gesture, we know already the ratio. We know that it's width. To increment to 1, I need to translate to the width of the screen. So ratio is width. And then we have index and length. Let's have a look. And you see here I'm swiping on the pan gesture handler. Actually, you cannot see where I'm swiping. You cannot see my finger at the moment, but here I am moving the top part. What I would do here is update the Spring config to finish a bit earlier. So I think I should have it here. Here I have my Spring config. So I use rest, speed, threshold. I put a fairly high value, same for rest, displacement threshold. So my, small oscillations are discarded and it finished early. For damping, stiffness, you can use this link. I can link to it in the video description. So you can, see, depending on how much bounciness you want, you can set up these values. So let me go into pan gesture handler. I have Spring config. I can pass it here as parameter of the Spring function. But I think it looks already pretty cool. Pretty happy. So here I'm swiping and swiping on the top, swiping at the bottom. So it looks pretty good. So guys, I hope you enjoyed this example. I'm looking forward to talk to you guys soon, and in the meantime, happy hacking.